Hi everybody, so this is the second video for today, Wednesday the 12th of August, and this video is a short lesson on how to calculate the total or effective resistance. Now last year in year 11 you learned how to calculate total resistance if it was in series. You didn't really have to know how to calculate total resistance if resistors were in parallel. So today I'm just going to work through a few examples. The first one is really simple, it's just two resistors in series. The second one's two resistors in parallel. The third one's got a combination of series and parallel. So I'll just give you some tips on how to do these sort of questions. So the first one, you know this already. So you always write the formula and substitute when you work through any question. So two resistors in series, your total resistance is R1 plus R2, so your total resistance is 4 ohms plus 4 ohms, and you end up with 8 ohms. So that's the answer to the first one. The second one, they're in parallel, so your total resistance is 1 over RT is equal to 1 over R1 plus 1 over R2, or 1 over RT equals 1 over 4 plus 1 over 4, and then you're going to get half, which is 1 over RT, so RT is 2 over 1. So that's one way of doing it. Another way of doing it is RT equals, in your calculator, if you do that, you're going to get the answer in one step. Okay, so you just go, when it's in parallel, so you just get that, so you just go open brackets, and I'm just going to bring my calculator close so that you can see what I'm doing. So you open brackets and you just go 4 shift that, so you get 4 to the power of negative 1, which is the same as 1 over 4, plus, and then you've got another 4 shift, and then same thing, close bracket, shift that. So what I've got on my calculator matches exactly what I've written on the board, and that's equal to 2. Okay, so you get the answer in one step. And the answer is 2 ohms. You never ever leave your answer with one significant figure. You should have at least 2 significant figures for your answer. So that's 1 and 2. I've just rubbed the board to make others don't get crowded. This one here, now it's a combination of series as well as parallel. So we do this in 2 parts. You're first going to find the resistance of what's in parallel, okay, and then you're going to add it to the 3 ohms, because for series you just add them. So total resistance in parallel, so you just go 1 over RT equals 1 over 6 plus 1 over 6 plus 1 over 6, or RT equals 6 to the power of negative 1. This is RT in parallel, and so all that you do, you can get 2 as your answer, but never mind, I'll show you the working. So you always open brackets. If you don't open brackets, you're not going to get the correct answer. So you just go 6 to the power of negative 1 plus 6 to the power of negative 1 plus, once more, 6 to the power of negative 1, close bracket, power of negative 1, and your answer is 2. Okay, so this simply means you can replace this whole thing with a single 2 ohm resistor. That's what it means. You've got a 2 ohm and then you've got a 3 ohm here. Now you add, these two are in series, so 3 plus 2, 5 ohms. So your total or effective resistance is 5 ohms. So that's how you do that. Okay, now I'm just going to do one more. I know, and there are some other bits which I haven't done, but this is how you do some of them. It's got subdivisions 2 and 3, you know, it's got a few more, but I'm just doing a few problems so you won't have a problem. You will know how to do the rest. I'm just going to solve question 4 because it's a combination of series and parallel, but in the parallel branch they're coupled in series as well. So I'm just going to draw the diagram first and then show you how to calculate the total resistance. So this is question 4. And you got one resistor here. You got a couple there. You got one here and then one there. Okay, let's get some values. So, sorry, it's not very good. So this is 1 ohm, that's 2 ohms, this is 4 ohms, this is 6 ohms, and that is 4 ohms. Okay, so I'm just going to redraw this. I'm just going to talk you through it. So you can actually replace these two in series with a single resistor, which is 6 ohms. So this becomes, so you've got your 1 ohm, and in place of those two, that can be replaced by a 6 ohm resistor, and that's 6 ohm as well. And this is 4 ohms. Okay, so this is the same as that. And then the next step, so that's your first step. You add those two, you get one value. The next step is you're going to replace the two resistors that are in parallel. So you're going to replace that by a single resistor. And in order to replace that by a single resistor, so you've got your 1 ohm. And then you got your resistors. So you've got 6 to the power of -1 plus 6 to the power of -1. Your resistors in parallel will work out to 3 ohms. You can replace those two by 3 ohms. And then you got that one there, your 4 ohms. Okay, and now you just add those 3 together. So 1 plus 3 is 4 plus 4 is 8. So your total resistance for that is 8 ohms. Okay, so that's how you do those questions. So your task for today is to finish those questions over here. I think that should do. I don't think you really need notes for this, but if you do, I'll just put up a Google Sheet where you can ask me questions and I can answer those. Okay, so bye for now, and I'll put something up for tomorrow's lesson later. Bye.